So we're with the Physics 3.1 higher tier test. It says here, the diagram shows a circuit used to investigate parallel circuit. When the voltage is varied, so A is the lamp L and the wire is W. The circuit has 3 ammeters, and let's have a look what it wants us to do. So the current through the lamp L and the wire is shown on the graph. So there's W, there's L. I think we've got to go to the next page to see what it's asking us. So it says there, use the graph to find the current through the lamp when the voltmeter reading is 6 volts. To do that, we need to go back to the graph. We need to have a look where 6 volts is. 6 volts is there. Okay. The lamp is this one, L. So I'm going to take it all the way up, all the way across, and it is 2. It's going to be 2 amps, which says there. Use an equation from page 2, calculate the resistance of the lamp at 6 volts. So we're looking to see what the resistance is now. So we know that the voltage is 6. We know that the current, we know that the current is 2, because we've just picked that up from the graph. So we just rearrange that triangle. Is it there? Yeah, I've used it. So I've covered R, which equals V over I. And then I just replace those values. 6 goes over 2. And that's going to give me 3 ohms. Find the current through the ammeter A1 at 6 volts. So if we go back to the graph, so find the current through the ammeter A1. So we know that current gets split in a parallel circuit. So we know that at A2, the lamp is 2. So that's why I've written 2 there. And then we know at W, if I go up there, it's going to come out to be sort of 1.25. Can you see that on the straight line? So at 6 volts there, it's 1.25. So that gets split. And we know that in a parallel circuit, the current always adds back up. So you can imagine that the current is maximum by here, and then it splits. So 2 amps goes this way, and then 1.25 amps goes that way. And then when they all meet back up, they're going to be 2 plus 1.5. And that's what I've done there. So it's 2 amps plus 1.5 amps is going to give me 3.25 amps. The voltage supply in the diagram is increased from 6 volts to 12 volts now. Compare the resistance of the lamp and the wire. So it wants me to compare. Well, let's have a look at 12 volts, what's happening in the graph. So at 12 volts, oh look, the wire's actually got, for 12 volts, the wire has more current going through it than the lamp at this point. So I would compare that, and I would say something like the lamp has a bigger resistance because it's got less current going through it at that point, even though all the way by here it's got more current than then. But at this point by here, see that crossover around about 11 volts there? The lamp is going to tail off because it's got more resistance at this point. So I've said that there. Give a reason for your answer. Well, lamp has less current at this point, 2.3 amps, compared to the resistor, which has got 2.5 amps. And I've sort of shown that there on the graph as well. So I'm showing all my work in. And then the last question on this page, as the voltage is increased from 0 to 12 volts, the power of the wire is not always less than the power of the lamp. Explain why this statement is true. Well, like I've just said, beyond 11 volts there, beyond 11, the W has a bigger current. So it's got more current. So it's not always the case that the wire will have more power, but at this point it will. And I can show that, I can demonstrate that down using this equation as well. Therefore, it must have more power. So I've said there that P equals I times V. Well, at 12 volts, the lamp is 2.3 plus times 12. So I'm just using that equation, P equals I times V. So there's your I, 2.3 times V, which is 12. That's going to equal 27.6 watts, whereas the resistor, because it's got a higher current, 2.5, comes out to be a higher power. And that's that. So let's put these two. I think I'm done with these now. Ooh, this one. This is a beast of a question. All right, then. Let's read it. And then we'll probably make another video after this, because it's going to take me about 6 minutes now. A light fitting consists of 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 40 watt, and I've underlined that because that's going to be important, lamps connected in parallel. They're all opposite each other. They are connected to a 230 volt mains circuit. Okay, let's have a look what's going on here. So we're looking at this. We've got the power supply there, which we know is 230 volts. We've got this variable resistor, which could be a dimmer switch. Okay, just like those dimmer switches you got in your house, which alters the lights, the brightness of the lights. And then we've got all these lights, 12 of them. Use an equation from page 2 to calculate the current. So it's looking for current now through each lamp. When all the lamps are operating at normal brightness. So we're assuming all these are normal brightness. So we're assuming that. So use an equation. So you pick out what you've got. So I know that I've got 40 watts. So I've got to have a P of 40. It wants the current. So I'm going to I there. And I also know my voltage. So I've got PVI. Well, the equation that ties these together is P over IV. To get my I cover I, and then I've got P over V. So I equals P over V, which equals 40 volts over 230. It gives me 0.17 amps. Okay, so that's that. So use an equation through each lamp. So there's got 0.17 going through each of these, because we know current gets split. Okay then, so the lamps are dimmed. Okay, we're altering everything now. At one dimmer switch setting, the resistance of the dimmer switch is 82 ohms. So this thing here is 82 ohms. And the power loss in the dimmer switch is 118 watts. Use an equation from page 2 to calculate the current. So we're looking at current now with resistance and watts power. So I need to get this. So this is P I squared over R. So this is definitely higher. Oh, I've just lost something. What am I doing now? I didn't want to do that. I need to go back. Wait, what have I done? I'm having a little bit of trouble here. How do I click off that? I do not want to do this. So, right. I was on the wrong setting. Sorry. Okay, I haven't deleted anything now, have I? No. So, what do I know? I know that R is 82. I know that my power is 118. Power loss, mind. Okay, and my I squared is unknown. So use an equation to calculate the current through that dimmer switch. Okay, so I'm just going to use that. So it's going to be I squared, because I covered up I squared, over P and R. P over R, which is 118 over 82, which gives me 1.44. But that's I squared E now equals 1.44. So to get I on its own, I need to take the square root of this. Because remember, I squared equals 1.44. Therefore, square root of both of them, you get I on its own. And then you're going to get 1.2 amps at that point. Calculate the power produced by each lamp in this dimmer switch setting. Now, the first thing you need to do is the power, because we're not dealing with, let's have a look here, calculate the power produced, oh, of course, yeah. So we're looking for power. So we don't know power, sorry. But the current, I'm going to explain how I've got 0.1 now, because there are 12 lamps, so the current through each is 1.2 here, okay, so because we're still going at this setting. This question can get confusing because you have to go back, because it's part of that same question. So B, you're assuming now that the current is 1.2, and the second part, calculate the power. So 1.2, so each of these, okay, so 1.2 is going to come out of there, and what do we know about parallel circuits? That it gets split, and they're probably going to get split equally, so I need to divide 1.2 by 12 there, and that's where I've got the 0.1 amps from. So my current is 0.1 amps. Now I need to know my voltage. Now because of that dimmer switch is altered really the voltage. Look, it's sorry, I can't point to that. It's altered the voltage, which is, yes, we need to put that into that equation, don't we? That 82 ohms. Yeah, so the way I've done this, there's a number of ways you could do it, but the easiest way to find this voltage, because you're not given a voltage, is to do VIR. And you know that at that point, I told you it was a beast of a question. At this point is 1.2 amps. And my resistance of that switch is 82 ohms. Therefore, I can calculate the voltage there. So I'm going to say V equals IR. 1.2 times 82 is going to be 98.4. Now, that's your voltage loss. That's why I was pointing at this before, because that's your power loss. You could have done it in a power equation, but then it gets confusing because you got that I squared. So I start with 230 up by here. So here's your 230. I alter this resistance, okay? So I need to minus whatever was lost then from my 230. So I've just found 98.4. 230 minus 98.4 is going to give me 131.6 volts. Now that I've found my voltage for this, now I can actually use that equation to find out the power for the lamp, and I think I've done it there. So I've got one. So where is it going to be? What have I trying to follow? What I've done here, or is it asking me for the voltage? Calculate the power. So where have I done that? There it is. It's by here. I missed it. I was just looking for it. Sorry. So P equals I times V equals 0.1 there times your 131, which I've just worked out here. 1316 is your answer. That was a beast of a question, mind, and I think I'm going to stop it there and do another video.